Okay, shall we begin our next exploration in data science? Okay, let's get started. So, till where we had seen, we have basically seen like um, till generating both the graphs, I believe. One was a histogram and with a, I think we did cover till here, right? In
No, sir.
our last
Above.
class. So we did see about the binomial, right? We did see about binomial, and then we were trying to see, did we see the difference between a normal distribution, binomial distribution? Yes. Yeah, here it is, right? So we did
Yes, sir.
see the difference between a normal distribution and a binomial distribution. What is a normal distribution versus what is a binomial?
Normal distribution is a which is closely how much the array, the mean value distributed, the data distributed around the mean value, which is non continuous data and not non continuous
Uh-huh.
and non distributed. It is closely distributed. Binomial
Which
is
is closely distributed, normal distribution is.
yes.
Okay.
Binomial is a it is outcome perform the series the test for which there are only two possible outcomes,
Mm-hmm.
which is uh, means we have like it is not continuous and which is uh,
Yeah.
we have zeros, we have middle gap, and then we have the data like this.
Okay. Okay. Raghav, what did you understand by a normal distribution and a binomial distribution?
I want to brush up the topic, sir.
Huh? Sorry?
I want to brush up the topic.
Brush up. Okay, okay. You want to brush it up. Okay, fine. So basically what has happened is the normal distribution and binomial distribution. Two kinds of distribution is there. So as Sashi was telling, normal distribution is basically for trying to find out the data points, whatever is there between a usual data where it can be like an IQ scores or a heartbeat, or where the distribution of the data is following a particular pattern of wherein we are trying to see whether how this data is basically coming out with. So basically it forms a, it requires three parameters: the mean, standard deviation, and the overall size of the records, right? So it is also called Gaussian distribution. So it can basically try to fit the probability of different events altogether. So that's where the normal distribution will come into picture. However, the binomial distribution is something are separate events like tossing a coin, the results that you get out of when tossing a coin. It can be, or it can be a height of people, right? So all these things generate more of a continuous values, right? So normal distribution is continuous, whereas binomial is discrete, which means the values will be different across for each of this. So I can assume it to be as our satisfaction scores, or it can be the male and female population, or it can be heads or tails. These kind of discrete things comes under binomial. So whenever the values are more of continuous and placed closely to each other, that becomes a normal distribution. Okay. So having said this concept there, Raghav, I want you to look into all these because we are going to go ahead with more advanced topics. So I don't want to you to miss out on the key things because these are like basics, right? So I want you to understand these things and go through the recording, spend some time on reading more, Raghav.
In binomial distribution, sir.
in both normal distribution, binomial distribution. Please go through our videos again, recordings again. Go through this and then you can basically come back, right? But for now, what we'll do is we are going to see a new kind of distribution. This is called Poisson distribution. Okay, so this is the third distribution that we are going to look into. Okay, so normal distribution, you know, it is more of continuous. Binomial distribution is more of discrete, right? But there is a new kind of distribution that is there. So let me ask you a question. Um, to a fruit shop, on an average, there are 3 customers coming every hour. Or every hour or every 10 minutes, there are 3 customers who are visiting. So here I'm going to ask a question. What is the probability of the distribution in case if there are going to be 5 customers who will arrive in next 1 hour? So I have a distribution of data for every hour, how many customers are visiting my store. Okay, I have that information with me. This is clear, Raghav Sashi. So
Yes, sir.
I am going to estimate what will be the probability of 5 customers coming in next 1 hour. Okay, so you see here the previously in the normal distribution based on a probability we are trying to put them across. In no, binomial distribution, what we are doing, we are basically predicting it based on the events, what is heads or tails, whether it will be head or tail. But now in this Poisson distribution, either we are saying what is the probability that next 1 hour, if there are going to be 5 customers who will be coming, right? So these kind of distributions are something like Raghav, you also told me in the initial class, I believe, if I remember it right, you were talking about how many tube lights or something can be manufactured in this many hours, and what is the number of things to be manufactured so that in order to meet the customer requirements, kind of, right?
Yeah,
You did
yeah,
ask something similar,
yeah,
Raghav. You told you have some understanding on this data, you have seen someone's notebook or something there where they were trying to find this. Yeah, can you explain what was that to Sashi also so that he can also get what was the problem you were trying to solve?
yeah. In stationery shop and supermarket also, we are asking how many customers per day are visiting our site. Some people have just walk up the customer. Some people have need to purchase the supermarket. And around 1 day of the supermarket, 10,000 people visit that. Only for 5 to 6,000 people of just come not buy it. Only 4 to 3,000 people only buying the product, and 10% people of buying about 20,000, or more than majority people only buying 20,000 as a deadline, the end of the day. So that kind of we gathering, and the product is mostly selling of our regular product of dal and rice. It's storing the market, but it's some certain quantity. It's distributing day by day, and mostly day by day increase the sales only cosmetics only. So that is the here we collecting data here, sir.
Okay, okay. So basically, what Raghav is saying is, Sashi, there is a demand. So what is going to be the demand for a particular product in next 1 hour or in next 1 day, so that I need to stack up my inventory. So depending upon what was my demand earlier, right? So I just see this is very crucial estimate, right? If you have seen in supermarkets and all, they have a time to stack up new things there. So people all are also aware of this particular timing because they get to see fresh products coming to their batch. And generally in big supermarkets like our Lulu, or in India also, if you see the D-Marts and others, they keep restocking. So the restocking is dependent closely based upon how many customers are coming and what has been the product's quantity there. So they try to keep things ready so that when a customer is there, it is said no to them directly rather than saying no, we always have things with us. And they also keep taking in more quantity. Right? So
Yes.
this concept is what this binomial distribution is basically going to help us. So it is basically going to tell us what is the probability of given number of events which are going to happen in a fixed interval of time. Either the time can be days, hours, minutes. It depends on the problem what we are trying to solve. Okay. So if these events occur, they are each of these events are independent of each other. We will be assuming it. So this is also a very important problem in banks and all, estimating the waiting time of customers. So how many customers are expected in this number of time? So what will be my average waiting time in my branch so that I need to deploy these many number of staffs or cashiers or people inside my bank so that I need to have my things equipped. So I don't want to have more waiting time inside the branch. I can sort out the issues of customers and then go on and on, right? That's that's a problem what we will be trying to solve here. Sashi, Raghav.
Yes, sir. It's about customer experience and inventory
Yes,
management,
the
people management.
demand, inventory management, exactly. So let's see the formula for Poisson distribution, right? Poisson distribution. So I would also recommend, Raghav, if you are getting your 10th standard, 12th standard books and all, statistics books, just try to get a grab of that copy because that will be even more helpful also. Okay. So the formula for a Poisson distribution is this. So the events what we will be getting that is represented by this symbol, right? By this symbol, and then what they are saying is, for example, consider a call center which receives an average of 3 calls per minute. Okay, so this value will be 3 at a given time of a day. The number of calls received in two given disjoint time intervals are independent, which they mean like it is new calls are only coming, not the same call is coming multiple times, is what they mean to say. So it has to be independent of each other. And then the K of calls received during any minute has a Poisson probability of receiving K is going to be the call of 1 to 4 calls, and the probability is going to be 0.77. 0 to 5, the probability is going to be 0.23. So likewise, when they are finding the value of lambda k e power minus lambda divided by k, they are basically trying to estimate a Poisson distribution. So, and also it is used in many other concepts there, but this is basically the formula for a Poisson distribution, but let's not worry much about the formula here because here things are taken care inside Python mostly. So you don't have to worry or try about why this is what value kind of, but you can just understand this, right? At a high level, you can just understand this
Yes.
formula. Um,
It is
not to worry.
mostly useful for the uh,
Yeah.
online marketing, mostly in the business side. It
Yeah,
would
yeah,
be
yeah.
like
Mostly in business or estimating, anywhere it is required,
yeah, yeah,
right? In an
anywhere, anywhere,
estimate, you
anywhere.
wanted to know either you can be as that example they had provided, they had given an example of call center. So
Yeah,
if
yeah.
three
Most
calls is
useful
expected in this,
in the
yeah,
okay. Which one you use
yes.
mostly, sir, in the normal
Uh,
binomial
he-
or Poisson?
no, it actually it's a combination of multiple methods, Sashi, because why we are seeing about all these methods is because
Yeah.
in our real time examples, what we'll be doing is we'll be adopting more than one approach, right? And we will be
Okay.
taking the
Yeah.
best of all. So in
Yeah.
statistics, there could be one method, more than one method, which will be supporting these things across. So we cannot say we'll be using only this or will not be using that. So it is a combination. So for us now, what we are doing is we are trying to learn various methods, how things are, what is useful kind of. And out of all these methods, now we'll see how we are going to make use of what and which is most useful for us. So that's how we'll be looking into these concepts. Okay. Raghav, are you with me? Are you able to understand this, Raghav? You already have seen this as an example, so I think it will be easy for you to relate it more.
Yeah, sir, but I want to study in the concept.
Yes, yes, yes. Yeah, please. I think you go through the previous
Yeah, that
topic
I'm
because
asking, do you have any notes? Please share that group. It's very helpful for we both of.
yes, Raghav, I have been giving you, I told you two websites. Out of these two websites, which one are you following currently?
Geeks for you.
Huh?
Geeks for books, sir.
No, 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 no. See, here, see, these kind of concepts, Raghav, what we are seeing, will not be there in one specific book alone, right? So it is a vast area. So certain concepts will be there in one. So that's why I gave you two website link. Have you been going through these websites there? One is geekforgeeks.com. One
Yeah,
is,
that time told you.
huh?
Geeks for geek.
Yeah, yeah, yes. Are you going through that?
Yeah, sir.
Okay. So if you are going through that, there are concepts for normal distribution, Poisson distribution, and this. Were you able to find those?
Hello.
Yes, Raghav.
Yes, sir. Sir.
I'm not hearing you that well, Raghav. The voice is breaking. Sashi, were you able to hear what Raghav was saying?
Yes, sir. They
No, sir.
learn the link, tutorial link.
It's
Hmm,
not clear,
still not.
Raghav.
Yeah,
Okay,
the
sir.
voice
Continue
is.
that. I will chat the message, sir.
Okay, okay, okay. Yeah, yeah. Yes. So what I meant is, if you are going through that links, Raghav, what happens is, let's look into the books, right? So this is not a school or this, right? We don't just
No,
go
sir.
by books
I'm not
alone.
Means
asking books. It's notes for
it's
like for how to that time as.
yes. Some of institutions they prepare their own notes or can means
Ah,
it is easy to make it means um
yeah.
check back go to through links. This is which is means mostly
Hmm.
the institutions some of follow the any courses they make a material for the means quick
Yeah.
recap these things like
Hmm.
data
Hmm.
science is vast course. We have many will come upgrades also, but
Hmm.
he's expecting that kind of notes. I hope so.
No, you mean to say so? My question here for that is, so what are we doing in class? We are learning that one only, right?
Yeah,
So
yeah,
and
yeah.
there
That
is a
one only.
recording
But
which is being given. Yeah.
yes, yes, yes. If we have
And
material, then it will be a cover in 5 minutes instead of watching 1 hour video
okay.
or like means. I think you understand.
Okay. See, here materials, as I told you, these are my personal experience collection of notes. Whatever I'm having, it
Yeah,
is in a
yeah.
form of my own handwritten things, right? So
Yes,
I
yes.
don't teach that school way of learning where there is a
Yeah,
book and we go by these concepts, right? Because I don't believe, right? Because no one is in interview, people are not going to be asking, okay, go to chapter one,
no, no,
binomial
not
distribution.
like chapter one. No, means all
Yeah,
topic which we are going to cover. This is what is the
yes,
meaning, what is the examples.
yes.
It is for students also. It is very helpful them if you means after 1 month completion of course. It will if
Mm,
they didn't noted, it will be recap for recovering. Means
okay.
when they
See,
going to interview.
My question is, all these notes, what you are seeing here,
Yeah,
are
yeah,
the problems what we are solving on day-to-day basis in the class, right?
yeah. Yes, yes, sir.
So if you are going through this notes itself, see
Yeah,
what we have seen here. We have seen about the normal distribution.
yes, sir.
Next, we have seen about the numpy and what is the
Yes.
mean, how to take the
Yeah,
median,
yeah, yeah.
scipy. So this is actually the notes what
Okay,
we
sir.
have
And
been
one
doing.
more my request, sir. Please mention the topic name, sir.
No, my question here is, Raghav, if
Yeah,
there are
okay,
things
sir.
to be spoon fed for you, what are you doing in the class? I don't see you are
No,
giving full
sir.
focus
Just
on
I
the.
have any doubt. You mentioned that for like a numpy is a distribution, normal distribution. You mentioned that easy to recollect the data, sir.
Okay, yeah, I get that. But my point here is, Raghav, you try to understand. Here we are in a industry, not in school, right? So here things will be expected from you to be done in terms of how you are understanding the concept. So why I'm giving you that assignment also, the reason is I want you to practice, put that effort from your end, right? So
Yes, sir.
I'm willing to give all the efforts from my end. It is on how much you are able to grasp that is what my question all about here is, right? See, here when you are seeing this formula, if you are practicing things after the class is done or when during the break when you are getting, you should know what is the formula for a binomial distribution, what are we discussing. So after coming in class, you are telling me, sir, I need to refresh the concept. So, see, now are you getting where exactly the gap is, Raghav? Right? Not only Raghav, I'm saying maybe Sashi, I
Yeah,
think
yeah,
you.
yeah, yeah, even me also, sir. I mean, we are. I'm not expecting this.
Yeah.
It
So
means
I'll mention
how.
the topics. Yeah, I'll mention the topics. But if you are have gone through all these concepts, everything we are doing it here in front of us, right? So how are
Yes,
we
yes.
importing the libraries? So you see, here only I can show you the answer for the assignment question, Raghav. This shows clearly you have not gone through what is there. You see there, I don't want to pinpoint you and say why I'm asking it is because see the concepts, whatever we are learning, I want you to practice that. For that only this notes is being shared with you, right? So here, how are we going to look for a number of dimensions? ND, you
Uh,
see,
dim.
what are we doing here? What is this, Raghav? Can you please answer?
It's a number of dimensions, sir. So like
Yeah.
print A
So
and
what was the assignment question I asked you for? So here we have the notes. Here we have the thing what we worked out on the class. I didn't ask you anything different on something what I didn't teach, right? See, ND men, what it is basically saying. This is basically the number of dimensions there, right?
yeah, sir.
So are you able to get where the problem is?
Effort.
Exactly. That is what is missing, Raghav. Right?
Yeah,
So
sir.
I understand your situation there. You wanted a job and you want to get into industry, but my point here is I'm showing you everything and I need the effort from your end
Yeah.
there,
Okay, sir. And
right?
you mentioned the topic about the for like a permutation topic. It's you
Uh,
mentioned that in the code. I will refer that. I have any queries, I search that, sir.
yes, you can ask me very much, right? So that's what I wanted. I want you to come out with, see here, permutation topic, you see. Yeah,
No,
that's
sir.
right. Maybe
You
I'll
mentioned the
start.
topic in the before starting the code. We anything I
Hmm.
have any queries, I refer that code. I clear the code.
Exactly. Yeah, yeah. I'll mention that. Yes. Going forward, I'll mention that. But my understanding was since we have already seen this code, So you have
Yeah,
an
sir.
understanding.
Already we find the code, but day to day we move to the advanced topic. If I any stuck the how to recollect in topic for like array topic, we mentioned that the code are easy to understand and what I mistake and compare your code, I rectify the error within some fraction of second. So that I am asking.
No, no, I get you, Raghav. See, here it is not point to argue, right? First, try to
No, sir, no
understand your distribution.
arguments, sir.
No, no, I'm telling you, Raghav. Try to understand. Here we are in a class where we are trying to see each of the concept in detail, right? So you can see permutation, how you can
Today,
say it's
okay, sir. For like example, today it's okay. After 5 to 10 days after, I forgot the any topic. You mentioned that
Mm.
here, I easy to solve that. So that time I asked.
Yes, I'm mentioning, even if for that only I'm trying to answer, if you are searching here as permutation, here there is a code. You see, this is for permutation, right? If you just search or type that keyword, which shows that you have totally not gone through any of this, right? If you have gone through, you will not be asking me this question, right? That's the point here,
Yeah, okay, sir.
right? See, I'm mentioning the topic going forward, but I'm okay to answer n number of questions of what you are having. But the problem here is I want that effort from your side to take up things so that you can also re-replicate it. So I'm not going to gain anything out of this, right? So I'm not sure about how things are, right? So, but from your perspective, I wanted you to get end-to-end understanding of this. So today's topic, what we'll be seeing is the Poisson distribution. Okay, so what is Poisson distribution, Raghav? Are you there, Raghav? Can you hear me?
Yeah, yes, sir.
What is Poisson distribution?
Just a minute, sir.
Yes, Raghav.
Sir, calculating the probation of the given number of event and occurring the fixed level of time and space.
Okay. Can you give me an example? What it is about?
Or like your supermarket one grocery item, it's completely completed. After how many time it's taking to refill and how many time it's take to reach the customer. It's time difference calculating, sir.
Okay. So basically, what are we trying to estimate here in a Poisson distribution?
Estimation. Which of the product, sir?
Sorry, it is basically going to tell us what will be the probability of a particular distribution in a given point of time, right? So it is going to be at a given point of time, what is going to be the distribution across is what we'll be seeing in a Poisson distribution. Okay,
Maximum
let's, yeah,
maximum time.
at a given time, at a given time. So at
Yeah.
a particular time, right? So here, what are we seeing? We are seeing about the probability distribution of answering a questions of how far, like 5 customers will arrive in next 10 minutes, right? So that is what something we are going to look into here, right? In the next 10 minutes, how many customers will coming? So that's something we'll try to estimate it here. Okay. So what we'll do here is we'll first import few libraries. So first, let me import Seaborn. So what is the Seaborn library used for? Sashi?
To make a visualization.
Yes. And this one, Raghav, matplotlib.
It's a graph, sir.
Okay. So what is actually the difference between a Seaborn and a matplotlib? Why we need to import both?
Seaborn, it's a bell curve, sir. MATLAB, it's a
Seaborn is a
rectangle.
bell curve.
Sorry.
Okay. Mm-hmm. Okay. So, Sashi, you have an understanding of why we are using Seaborn and matplotlib?
Yes, sir. Seaborn is a high level visualization library, sir,
Uh-huh.
which need to import.
Yes. Yes. So yeah, the basic difference is matplotlib is mostly like a low-level plotting library. Basically, it provides us the fundamental building blocks of creating wide variety of statistical and animations and things, visualizations. However,
Giving the
Seaborn
option
here,
colors, this are changing
yes,
the,
yes, exactly,
yeah,
exactly. So
that
Seaborn is
is like
something which is
customization.
exactly, exactly. Seaborn is the one which is built on top of matplotlib, right? So it is built on top of matplotlib, which provides us a even higher level of interfaces and creates us an attractive visualizations,
It's
right?
like we
So
can think like, for example,
yeah.
Power BI, we have Power BI like Seaborn and configuration like MATLAB.
Yes, so matplotlib, what it can do is basically, so matplotlib is like ABCD and Seaborn is like words and paragraphs, right? So without ABCD, you cannot, but Seaborn was built on top of that in order to provide more statistical focus, more of these aesthetics. So as Raghav was saying, sir, this is designed for building normal distribution, right? So it is statistics is more in Seaborn versus here it is less of basic things will be available. So that's
Yes,
the basic
low
difference,
level.
right? Exactly, exactly. So I want you to ask me such questions, Raghav and Sashi, to stop me if I'm using something. I want you guys to think on why are we using this?
Yes,
And
sir.
if at all you need to also stop and ask, like, sir,
Inspire.
why this library is used? What is this line happening? And just don't get carried away with the syntax alone. Syntax, let's keep it separate. We know that we can anyway do that, right? So don't remember the syntax as I'm saying it to you in the first class until here also. Don't remember the syntax. Remember what is the concept? Try to go
Yes.
through the same again from your side, right? So try to, before the class is starting, at least spend like half an hour or so in your office or take a printout of this and try to see like what concepts we saw and do some exploration during your free time, right? So
Yes, yes.
without our effort we will not be able to learn data science here.
Yeah, okay, sir. I understand.
This is not a university to.
Yeah, no, it can, it see
It is
in
not a.
university the
If you learn or not,
problem.
it will go continuous.
Exactly, exactly. It will, they'll just leave and go. They'll give you some reference book, read from there, and that's what it will happen, right? But here the problem is what I'm seeing in day-to-day activities is we are conducting interviews for various data scientist roles, or for business analyst, and this the people totally lack basic understanding of what is to be done without knowing on probability distribution, without knowing on Poisson, binomial, these guys are building models. If I'm asking them a question of very basic statistics, they don't have an understanding of that. If a person is doing that way, how are they going to survive in this market? Right? So, almost 2,000 people we have recruited. Still, we have not found a particular suitable position for my team. We are still in search. We are still searching. Almost 2,000 profiles shortlisted. We are not
Raghav,
able
please,
to
in next
identify.
1 month, you will be SAR team. Please read.
Yeah, so if you are coming to my team, it's going to be even more difficult, Raghav. So,
Day
so
by
it is going to
day, I increase my skill set because I have two-way platform in standing.
yes,
When you
no, no,
enter in
don't
the company, there is no day by day increment. Directly
yeah,
forcing
yeah,
See,
AK
once I
47.
yes, I agree that, and I moved to the data science role and full focus and dedicated to deep learning and for. But I am now I am standing in the two-way track. One way is
yeah,
data science, the other way is I'm already told you real estate. So two is a
mm,
different way track. But
yeah,
data science, how to implement in the real estate, how to calculate, how to and anytime I
mm,
think about the data science, how to implement the supermarket, how to implement the real estate. So that
yes.
thing
Oh,
keep in my mind.
okay.
Hire
No,
one
that's
person. We
good
will
to
give
know,
you.
Raghav.
I think
Really,
your business point of view.
enthusiasm. I really admire your enthusiasm, but the missing piece of this puzzle is what is happening is I think you are too much focused on certain things alone, outcome alone. But the problem here is when we are too much focused on outcome, right? As it is told in Bhagavad Gita, don't just focus on the result, do your duty, right? The same thing I'm telling you, do your duty, which is to study, right? Just focus on learning only and
Don't expect
come up.
that result.
Yes, the result will automatically follow, right? Don't run behind the result. If you are running behind the results, you will not get there.
We do
So,
the karma.
yes, do your karma and don't worry about the result.
Yes, sir, I eagerly learned to data science and within end of the year, I want enable
Yes.
the job in data science role.
Yes, see, we are going to do a home price prediction. We are going to do at least a stock market, at least try to understand the market, if not a stock market predictor, at least we are going to create a chatbot and do things, right? So all these real-time problems, what I want you guys to do is, I want you to publish all these problems in your LinkedIn, whatever we are going to solve across, right? I wanted your solutions to be published there. You see, now people
Data
like
science, sir.
Sridhar, yeah, yeah, exactly. The data science projects, whatever we are going to do, I wanted you guys to publish that project step by step in Kaggle on and also in LinkedIn. So that's my, I'm just preparing you guys for that purpose only. So what I need from you is just that extra time. So whenever you are having a free time, like lunch or this, if half an hour you take for lunch, take 15 minutes, remaining 15 minutes, try to study what are concepts we have gone through. Try to go through the materials or the links that I have given, right? Because I don't want you to confuse with more and more information, but I'm planning to share you some books and things also at a later stage. But now I don't want to give. The main reason is because our focus will get deviated if we go there, because they would have given so many things there. But what we need is from industry perspective. So that's why I'm keeping your focus like a horse at a straight only on these learning these concepts, right? So, right, moving away from the rest of the distractions. Okay, fine. So, next module we are importing is NumPy. So, NumPy also we'll import. So, we'll say import NumPy as NP. Okay. So, since we started the class a bit late, maybe we'll just take 10-15 minutes more, okay, as we were spending more time on other things. So now, how are we going to apply this Poisson distribution? Okay, so for applying this Poisson distribution, what we are going to do is, we will first need to create a class methods for Poisson distribution. Okay, so what I'm going to say here, first let me create a NumPy array. Okay, so I'm going to say for np dot arrange. So np dot arrange. Yes, I hope this is there. Equal to, sometimes some of these arrange I'm not sure if this arrange is there. Okay. So first we have to import Poisson. So we have not imported Poisson itself. So from scipy.stats import Poisson. So this is very important. Okay, because this is the library which will basically help us to create a Poisson distribution across. So how are we going to create this Poisson distribution? We will first create a sample method, right? So here what we will do is, so there are various methods in Poisson distribution. Okay, so we are going to see each of these methods or something like what we'll be mostly using, right? So first what we'll do is we'll assign a value of x. So the value of x here, what we'll do is we'll say arrange, or how are we supposed to create an array here? Raghav, Sashi?
Hello.
Dot array. We get
Dot np dot array.
no, sir. We give
Okay,
the
so
data.
yes.
We
Okay,
set
so
the
before
array
giving
data.
the yes, so let's first import all these libraries so that we'll be getting this. Okay, so what you are saying,
We need
first
data,
we'll
sir.
need, okay, I'm going to import the data. So what data I'm going to give? So how am I supposed to give that? So
Random.
here,
We
this
cannot.
is a new,
You are not getting from random.
no, not from random. This is a new
Okay.
method what I'm going to give. So what this method is going to do is, this is nothing but an arrange method, right? So this method, what it is going to say is, it is basically going to arrange a certain numbers. At a certain given interval of time, it is going to arrange a certain set of numbers. As you can see here, returns evenly spaced values within a certain interval range. Okay, what it does from a start position and a stop position, I'm basically going to give. So let's see an example for this, right? So this is how you can see the examples also. So always I'll recommend you to not remember the syntax. Just try to see the examples and see the syntax from here, right? What they have done, they have said a np dot arrange of 0, 5, 0.5 d type of int. What are they doing? So here basically they are trying to arrange a set of numbers at a specified interval. So, and what is going to be the type of this? It's going to be an integer. They are giving some few parameters to this. So let's for now take only two. So I'm just going to say 0, 10. So I'm going to say arrange numbers starting from 0 until 10, and I'm going to assign this value for x. Okay. So next what I'm going to do is I'm going to declare a variable PMF. So what is this variable going to do? This is where my Poisson distribution will be there. You see here, I have to give this variable as Poisson.pmf. PMF is nothing but probability mass function. Okay. So here I need to tell you guys what is probability mass function. So you know probability. Can you guys guess what is probability mass function?
Massive data.
PMF.
It will arrange.
Sorry, Sashi.
Means it will make a probability from massive data. Massive
Um,
means a huge data from huge data itself. Or
uh-huh.
but
Okay. And Raghav, what do you think? What is this probability mass function?
Getting a possible pair of data.
Mm-hmm. Okay. See, this probability mass function is what is basically it is going to give us a probability. You are right, right? It's going to give a probability of a discrete variable that is exactly same to some value. So this basically in statistics probability mass function is also called probability function or frequency function. So what this does is probability function that gives a probability and it assigns to a discrete random variable. So which is equal to some values there. So it basically gives a particular probability and assigns it to a discrete values. Okay, so for example here, probability of getting a specific number of heads when flipping a coin multiple times. Example, if I wanted 2 heads, so basically this is going to assign the probability for each of the heads I am going to get. If I'm asking for 2 heads, it tries to assign the probability for these 2 heads. What will be the probability? So earlier probability, what it does, it just assigns for only one event, right? Either head or tail. So what if I wanted 2 heads, 3 tails? Right? What will be the probability? In that case, I'll be making use of probability mass function. So that is what I'm doing here. This is available in Poisson, which is there in my SciPy library, scientific Python. And I'm going to import the scientific Python.stats. From there, I'm basically going to import this PMF. Okay. Are you guys with me, Raghav Sashi?
Yeah, yes, sir.
Yes, sir.
Okay. So
Is there
here what I'm
any,
going to say, yeah.
this is only the function, or we have any multiple functions for same, can utilize basically
For Poisson distribution, you mean?
um, yeah, this kind of
Yes.
function, Python for
Ye-
binomial and normal distribution as well.
Yeah. So for Poisson, we generally use the probability mass function. Basically, this helps us to, as this is told, it assigns a value for a particular distribution. So because as you saw the equation, there are 3 parameters. We saw one about lambda, one is k,
Yeah.
and one is that values we need to give. So basically, in order to give these values, what we are doing is we are giving this through a mass function. So here, what I'm saying, for every 3 records, kind of try to find out. See why I'm assigning it as 3. So what is my question? So what was my question here? So in a fruit shop, I'm also mentioning the question for your future reference. In a fruit shop, average, there are 3 customers who arrive every 10 minutes, right? And here basically my value of lambda, I'm just mentioning it as lambda, BDA, lambda is 3. Okay. So why I'm assigning it 3? Because for every 3
10
customers
minutes.
are coming every 10 minutes.
10
So why
minutes.
I'm assigning here 10? Because the number what I need is 10 minutes. That's why
The
I'm
time.
creating an array and then arranging it as 10. And for every 3 minutes, I'm getting 3 customers. Every 10 minutes, I'm getting. So hence, I'm saying here as 3. Okay. So here, what are we going to say? What will be the probability of getting 5 customers in next 10 minutes? Okay. So this is my question, Raghav Sashi.
Yeah.
Right? So this is my question. So for this question, in order to solve this, I'm basically assigning these values. Okay. So that's why the X I'm arranging it as 10, 0, 10. So every 10 minutes I get a new customers. So my interval is going to range from 0 to 10. And what is this? This is 3 customers are coming. So first I need to find out using my Poisson distribution. I wanted to see how this is working. Right. So here first I need to know, like for my Poisson distribution, I need to give or input this data. Then only I can predict from this what is happening. Okay. So till here, is this clear for you guys?
Yes, sir.
Raghav, is that clear?
Sir, you arrived every 10 minutes, we mentioned the 10. And you
Yes.
mentioned the 5 customer in next 10 minutes. It's also 10. But next 20 minutes, we give that to what we do, sir.
So next 20 minutes, what will be done? This 10, we are going to change it as 20. So it is going to be from 0 to 20, right? So this is will be
So
10.
arrange
Because,
value, we need the time space. Okay, sir.
yes, exactly. The interval we need. We need the interval. So the Poisson distribution itself will work only based on intervals, because as I told you, the number of events that will be happening in a fixed interval of time is what we will be estimating in a Poisson distribution. Right? So I'm not considering if same customer is going to come again. So I'm assuming these 3 customers who will be coming are independent of each other. They may not be the same customers. I'm assuming them to be as new customers only. Okay. You are with me,
Yes,
Shashi?
sir.
Yes, sir. Yes, sir.
Okay. Perfect. So now what I'm doing, I have taken 2 values. One is my X, the other one is my PMF. PMF is what is my Poisson distribution, my number of customers. So now what I'm doing, I'm just visualizing that graph. So using what? Using Seaborn, I'm just visualizing. So I'm saying this particular distribution, what we are going to show, this should bring up our Poisson distribution as a graph altogether. Okay. So let's first see. So for visualizing a bar plot, you see what has happened? It is saying 0 to 1 positional arguments, but 2 were given. So basically the bar plot can take only 0 or 1 argument only. Right? So what I can do, I cannot use a bar plot. Okay, let me do something. So here
Like,
bar plot is something it cannot be used because it accepts only 1 argument. So what are we supposed to do? We will not be able to visualize using this. So instead of a bar plot, let's try this option. What is this PLT? It is a matplotlib.py plot. Okay, let's see this, whether this is coming or not. Okay, you see here. So this is basically giving me a distribution on my x-axis. What is there? My x-axis is the interval. My y-axis will be my probability. Okay. So basically I have not labeled my graph yet. Let me label this so that you know what is what. So how to label a graph? I can just say plot dot x label and y label is there. You see, these 2 parameters I can give. So my x label will be my x-axis, y label will be my probability, right? So basically what I'm doing here is my number of customers is given in x-axis. The probability of the customers who will be coming will be given in my y-axis. Okay. So I'm saying for every 10 minutes I have found this probability, right? So the probability is highest where, see, this is maximum probability that is coming is how much? Sorry, I'm not able to move this. Let me, yeah. Okay. So what is the maximum probability that I'm getting here?
2 to 3.
Sorry?
It's 2 to 4. 2 to 4.
Yeah. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has just estimated for my 10 minutes. Okay. So if at all, I'm just going to say this is for number of customers. This is not time. This is basically
Yes.
my probability, right? So here I'm saying 2 customers coming, the probability is the highest across. So 2 and 3. So based on the distribution or this Poisson distribution, what it is predicting is if customers are going to come every 10 minutes, the customers are going to be 3 customers, then my probability of who will be coming in next 10 minutes will be maximum will be 2 or 3 customers only. And next 10 minutes also. Okay. Let's now put this as a problem. If you are saying 20 minutes, let's estimate. If there are 3 customers going to come and every 20 minutes for me, what will be the probability that the number of customers who is going to come in after 20 minutes? You see? Now the probability has come down. Do you see that? How much it has come? It has come down to 1.5. 1.5 to 2 customers only will be there in next. So maximum probability for you. So since I gave it as 20, it is assuming for every 20 minutes there will be a customers, but maximum customers who will be there will be in this range only, maximum. Right? So basically what this is helping us do, it is trying to assume a particular probability and it is trying to put across a distribution across for that probability. Are you getting this, Raghav, Sashi?
Yes, sir.
Raghav, are you getting it?
So probability is a time-based showing the data, sir.
Yes, it is a time-based data only. So basically it works mostly for a discrete problems. Discrete is what? So it is basically number of customers. We need to know the number of people here. So the outcomes has to be countable. So it can be 1, 2, 3 likewise. And it has to occur in fixed interval of time. And each event is considered independent of each other. Right? So depending on this, we'll be able to predict on this Poisson distribution further. Okay. So, right. So basically what we have done here, we
Can
have
we predict?
taken. So now I'm going to give you a problem. Okay. So this particular problem is what I'm going to say, assume a call center is there. Okay. A call center is receiving an average of 10 calls per hour. Okay. In 1 hour, we are going to get 10 calls. Okay. So what is the probability of receiving exactly 7 calls in next 1 hour? Okay. So how am I supposed to estimate it? 7 calls in next 1 hour. What is the probability of getting 7 calls in next 1 hour?
7 calls in next 1 hour.
Yes. So I'm repeating my question, or maybe I'll type the question in this row below.
No,
Okay.
just tell me, sir.
So call center is receiving 10 calls per hour.
Okay.
If the probability what will be the probability of receiving 7 calls in next 1 hour? So this is my question, Sashi, Raghav. Can you tell me how are we supposed to distribute this, find the data in this Poisson distribution for this? What will be our lambda first? Tell me what is my lambda, Raghav?
Or,
Yes, Raghav. What is my lambda?
uh,
So lambda is basically this value. Yeah.
Six-
lambda the
s-
x-axis
60
values.
minutes. 60
Yeah.
minutes.
Okay. So what will be my lambda, Raghav?
60.
I think it's a time, sir.
Yes. Okay. Okay. Lambda will be my time. Okay. So what will be the time here? I told 1 hour.
No, it's 60 minutes.
Uh-huh. So 60 minutes can be taken as. So what do we want to average number of events is what? So what do we want to find the probability for? We want to find for what?
Next 7 one within column 1.
Okay. Let's take a separate problem here. Let's solve it. Okay. First, we have imported all the events and the value. So lambda, or since I'm not able to say it as lambda, I'm just saying as mu also can be told as lambda. So what is my lambda here? Average number of calls, how many I'm getting? That will
10.
be my lambda, which is 10. So 10 calls I have told. So my lambda is 10 here. Okay. So next, let's go on. What do you want to predict? Yes, you want to
Probability
predict?
of 7
Yes,
calls.
exactly. So I'm just saying the value of something called k equal to 7. Okay. I have assigned this. Okay. Now I got this. So now what am I supposed to compute? I need to do what? Probability mass function I need to do, right? So what I'm doing for that, so I'm assigning a variable called probability, and I'm assigning the value of my k, which will be my prediction, and mu, which will be my actual 10 calls I will be getting, right?
7 comma 10.
Yes. So I'll be just doing this, right? So now what am I supposed to receiving exactly 7 calls will be what? Let's estimate the probability. Since it is 1 hour I have told, so the time range will be 1 here. So here we need not directly mention it. So it is by default, it will be taking it as 1 hour. So you don't have to mention. And you see here, if I'm just going to predict the probability alone for this, how much it is? The probability,
0.9.
which is
0.9.
9%. So your probability of going to get 7 calls in next 1 hour is going to be 9% or 0.9. This is what is represented there in the graph also. Okay. So in this graph is also trying to estimate that one only. So the number of customers across various times, it is trying to give a probability. But since we asked for one exact number, we are trying to substitute that value and we are trying to get this function. Okay. Are you guys with me, Raghav, Sashi? Are you understanding what is happening here?
Yeah, understanding, sir.
Hmm.
First,
Okay.
you mentioned the 10 calls receiving 12 hours. Second is receiving the 7 calls in 1 hour. So
Yes.
what we will find the data? We mentioned the 7 calls and 1 hours. We don't focus the 10 calls or 1 hour, sir.
No, what has happened here is basically we are going to take this value. So since we have given 1 hour, right? So it was assuming only next 1 hour is something that is by default. It will, we need not specifically mention that hours here. So as you had mentioned it previously, since it was just in minutes, you just created that and then you passed on that parameter 0, 20 as a parameter to this. And then you told it is going to be 3 customers. The probability is going to be what? It is basically trying to estimate this. So here, since it was just 1 hour only, we didn't specifically mention that time range. It was by default assumed to be as 1. Okay. So that's why this was currently not considered over for specific time range here in this problem.
Yeah, okay,
Okay.
sir.
Are you getting this? See, what I want you guys to do is look in for more real-time problems using this Poisson distribution tomorrow and come out with some more questions and try solving some of them also from your end, right? So that is the way to learn these concepts there. See, I can show you a few examples, and but there are n number of concepts that are there on top of this, right? So what is the best way to learn this? I'll tell you. Just go there to Google. Nowadays, this Google AI is there. This is even more convenient, right? So whatever concept we are learning, so just try typing in this AI mode. Not sure why this AI mode is not coming. So I know, I hope you guys know this, right? Google AI or this
Yes,
is
sir.
there. Okay. So
Both.
or you can search with
Gemini
AI.
AI.
Yeah, Gemini AI. Right? See, just type in Poisson distribution. Right? Just type in Poisson distribution. It will not give you from one site, it gives you from multiple sites. You see, there are links, there are examples. You see, there is
Yes.
a video from Data Camp which is available here. See
Yes,
what
sir.
they are
That
saying,
is
using scipy.stats.poisson, looking for this module. So they are talking about probability mass function, what we just discussed now. PMF gives a probability of getting exact number of occurrences. You can calculate this using the Poisson PMF function. So what they did, average rate they came, that is mu or lambda, and the number of events they mentioned as 3. So probability of 3 calls, what they are saying, k comma mu, and it is going to give us a probability. See, I just showed you about PMF only. I didn't show you CDF. So CDF is something what you guys need to learn and come to know, right? And similarly, more than k events. So if it is going to be more than more than 4 events, so it means like you need to find out whenever it is going to occur more than 4, right? So total number of events you are just going to give 4, but you wanted to compute for 5 events or more than 5 events. In that case, how are you supposed to calculate? You see here, everything is given with examples. So how are we generating the sample here? Please make use of this Google AI, guys. This is really, really helpful. See, here also they are arranging it 0, 15, and then they have put very similar examples what we have done, right? and they are trying to show the Poisson distribution and do things. And in case if you are not convinced enough, there are few videos also here. So that's the
Yes.
reason why I didn't recommend you any books alone. The reason is because I wanted you guys to look in for these resources there, because this is a new concept. Whatever we are doing it, they might have given an outdated examples in books, which will not be real time for us to apply and see. So let's look in for these kind of resources there and try and doing more of these steps. So this is how you can learn across, right? Not only a single concept, we can learn multiple things across, because now after we cover these distributions and these concepts, we will be jumping into more advanced topics now, and we'll start solving problems going forward, right? So before I go on with our um, this what is that, our visualization, right? So I wanted to cover and make sure that you guys are having an end-to-end understanding of all these concepts.
Yes, sir.
Okay, Raghav, Sashi,
Yes, sir.
I know I have taken more time of yours, but definitely since I wanted to emphasize the importance of learning this, and it is no more just time pass. The sir will come, he will just shout and go, then I'll forget the concept. No. Right, so you have to learn. You have to put out, take out
Research.
some time, do that painful part. No. So if you are not doing that hard work, you will not be getting that result what you are expecting. Raghav, sir.
Yes, sir.
Especially for Raghav, sir.
Sorry, Raghav, what was that?
Yeah, it's especially for Raghav. Sasi also catch the points.
No, I didn't, I didn't get Sashi also.
Sasi also follow with you, sir.
Yeah. Yes. Sashi should also follow me, and you should also follow this, because why I'm saying more emphasis on you is Raghav, because I want you to get into the industry first. So more scoldings will be for you compared to Sashi, because he is already there and now he needs to move to data science alone, but you need to enter into this industry itself. So more push is required for you. Hence, I'm emphasizing that even more. So maybe my scolding will also be more for you, Raghav. So in case if Sashi is not taking it seriously, then I think he will also be getting the same.
No, sir, I am taking seriously. I have planned for a long time, but it is not happen. Now it's time to do.
Yes. See, if we are just learning it.
It is like two benefits are one kind of job, one kind of main personal
Yes.
also. So
Yes,
should
we
it
can
should
apply these concepts anywhere. So
yeah,
now
yeah.
we'll be seeing these applications of this Poisson distribution in real time, right? So once we start solving the problems, you will get to see.
Yes.
Okay.
Okay, sir.
Okay. So I just will give you one question for the assignment. See,
Yes, sir.
I'm having a branch. So in my branch, I wanted to estimate my number of customers who will be coming to my branch. Okay, so here I already showed you an example of this Poisson distribution. My question here is, okay, so I have a branch. So I have 100 customers coming to my branch from, assume morning 9 to 10. 9 to 10 a.m. Okay, I want to estimate the number of customers I will be getting in next 1 hour's time. You are getting right, Raghav,
Yes, sir.
Sashi?
Yes, sir.
So this is the question I want. I want you to create a function and solve this and let me know your output.